Hey guys, how's it going? This is Carl again. This is week 5, problem number 5. So we'll go ahead and get started. Multi-generational families can be categorized as having 2 adult generations, such as parents living with adult children, skip generations, such as grandparents living with grandchildren, and 3 or more generations living in a household. A survey was conducted on multi-generational households, and the reported results appear in this accompanying table. Use the table to complete parts A through C. So what we're looking at here is kind of basically a contingency table, as they call it. And from this, you can derive probabilities. Now, when we talk about this, what do we mean when we say deriving probabilities? And so you have this sample, and you want to find out what's the probability that, say, nationally or regionally, however you want to apply it, depending on where this sample was and how it was taken. What is the probability that a multi-generational family is Asian? So from this data, what can we say about what is the probability, what is the chance, essentially, that at random, a family, multi-generational family selected at random will be Asian? And so what we do here is basically just kind of an arithmetic solution. We are getting at the um, the numerator and the denominator. And so in this case, what we're going to do is just we have to find out the total Asian population here. And so that's basically just looking across. So you have your total here. So out of this survey, 110 multi-generational families were Asian. And then we take that, and that's our numerator. Denominator, as you can imagine, is the grand total, the total of the totals, which is right here, 1438. And so if we want to do a probability of, with respect to this question, it's just simply typing this in, and our denominator is our whole population. And so we get 0.07. So what does that mean? That means that there is a 7.6% chance that at random, a multi-generational family selected at random will be Asian. A 7% chance, which makes sense given the fact that the size of the cohort and then the size of the actual investigative group you're looking at. The next question is, what is the probability that a multi-generational family selected at random, remember, is Hispanic and 3 or more generational? It includes 3 or more generations. So this is a little more dynamic question. So, but really, all you're really doing here is looking for the numerator. You already know your denominator is 1438 in these two questions. That's what it is. But you're really looking at your numerator. And what is the hint at the numerator? It's right here. You're Hispanic and 3 or more generations. So it's almost like, you have your X and Y. You're plotting your point. So you know your Hispanic row is right here. This is your total Hispanic population based on our data. And then you want to look at 3 or more generations in the family. So right here. So similarly to our previous question, so 139. So the probability that at random, a multi-generational family selected at random will be Hispanic and include 3 or more generations is this number right here, divided by our denominator, which is right here, which is 9% chance. So actually, there is a 9.6% chance that at random, a multi-generational family selected at random will be Hispanic and include 3 or more generations. So interestingly, there is a higher chance of these two conditions being met than the single condition of being Asian. So just interesting looking at data and probability. And what type of probability is in part A? Part here is a marginal probability. It's not joint because, as you can tell, there is no joint conditions. So, and this is basically kind of in just how you do probabilities and how to calculate them based on an output. What we've done previously in terms of observed and expected. This is kind of what we're doing here. Observed values and expected values. It's a little similar in terms of calculating probability. So we hope this helps, and just let us know if you have any questions along the way. Thanks so much. Bye-bye.